Welcome viewers, this is Isaac LUKYAMUZI, aka Teacher Isaac. I teach science. Let's go straight to the point, and before that, remember to subscribe to our YouTube channel so that you can always get the notification every time we upload any video, so that you don't miss out. Previously, you looked at moments. We are still looking at the same topic, that is friction and machines. Moments, we shall remind ourselves about a few tips. Remember, we discussed that in order to have this moment, the plank balancing, or in a state of equilibrium, we normally say it is in equilibrium, meaning it is balancing. So it has to balance. So in order to balance, you have to look at the left-hand side and right-hand side being equal to each other. How do you do that? Remember, you were told that we have the load, we multiply it by the distance from the pivot, right, together, and that is called the load arm. So in the previous lesson, you called this LA, that is the load arm, okay? Now, we also have the effort this side, which has to balance with the load this side, and it is X distance. So this is the effort arm, this side. So in order to have this balancing, we shall make sure that this side is equal to this side. As simple as that. So in our question, they are telling you to find the value of X in the figure below. X is the effort arm. It is what they are telling us to look for. So we need to calculate that, okay? Now, the principle of moments, it always states that the sum of clockwise moments are always equal to the sum of the anti-clockwise moments. So, let's first look at the moments this side. That is the load force multiplied by the load arm is equal to the effort force multiplied by the effort arm. As simple as that. Dear candidates, don't forget to state this, because the moment you don't state it, you are losing a mark. The examiner gives you a mark for only stating this. This is what will help you to substitute these figures, okay? Now, let's look at the load force. The load force in this case is 5 kilogram force. We can eliminate the units at this time. 5, we shall multiply it by the load arm, which is 3 meters. The load arm is the distance of the load from the pivot. So that distance is 3 meters. We shall multiply it by 3. This one is equivalent to this side. We shall look at the effort force multiplied by the effort distance from the pivot, called the effort arm. In this case, the effort force is 3 multiplied by the effort arm, which is X. I would prefer using that X. All right. Now, our work is simplified. We just have to solve the equation. Very simple. Let's go ahead. 5 times 3, that is equivalent to 15. I think everyone can do that. Equals 3 times X, we shall get 3X. What do we do in order to get X? We shall divide both sides by 3. In this case, we shall have 3X divided by 3, 15 divided by 3. Divide by 3 this side, by 3 once, by 3 once. So this side we have X. Let's divide by 3 here, once. 3 goes in 15, 5 times. Very good. So our answer will be 5. Now, 5 what? Some of you leave it there hanging. X is equal to 5 because I told you to find X, but X should be in meters. So in other words, the effort, the effort arm, which is represented by X, is what we have now discovered as 5. In this case, it is 5 meters. As simple as that. That was a recall, it was a reminder of what you did previously. Now, today, we have some other numbers which seem to be complex, but are not complex. They are easy. We shall follow the same steps that we've used to calculate this example. So in this case, we have number 2, find the value of X in the figure below. Find the value of X in the figure below. I'll give you a live example. I'll give you a live example of a ruler. I'll give you an example of a ruler. A ruler can be used as a seesaw. In this case, we shall have this as our seesaw. Now, take an example. If your dad sits on one side, your dad is heavier, definitely. And both of you sit on one side. What? Shall we have this ruler balancing? This will be like a seesaw where we have one person, a big person on this side, and 2 different people on this side. Okay? These 2 people must balance the fattest person on this side. So that is the kind of example we are going to look at. In this case, take an example that this is your dad, and you and your sister are supposed to balance your dad on a seesaw. Okay? It has to be in a state of equilibrium. All right, let's go ahead. We shall first of all state the principle of moments. Remember, we said the load times its distance from the pivot, which is the load arm, is equivalent to the effort multiplied by the distance from the pivot, which is the effort arm. Are we together? Don't forget that. Always state that. Simple. Load force times load arm, okay, is always equal to the effort force times effort arm. Now, be careful at this moment. You can realize that in our diagram, we have two efforts this side. That means, let's call one effort, effort 1. Let's call the other effort, effort 2. It so applies to their distances from the pivot. Distance from the pivot here will be effort arm 1. Are we together? Then we shall have effort arm 2. Okay? That is the only difference. Remember the previous example, we've been having one weight this side, one weight the other side. Now at this moment we have 2 weights on one side to balance one weight on the other side. Are we together? All right. Let's try to change our formula a little bit. We shall have load force times load arm multiplied equivalent to the effort 1 times its distance from the pivot, effort 1. Are we together? In this case, we shall be adding these 2. Okay? We shall be having, we have 2 weights from the other side. Are we together? We shall multiply this times its distance from the pivot. Are we together? You can call it force 1. Oh, sorry. This should be effort, force 1, effort force 1. Okay? Multiplied by effort arm 1. We shall then add effort force 2 times effort arm 2. Be careful here. This one really confuses many candidates and they end up losing out marks. Are we together? So the issue is very simple. You are going to see as we go ahead. Let's first substitute now. Our next step is to substitute. The load this side is 15 kilogram force. 15 multiplied by the load arm. Distance from the pivot, very simple. That is 4 meters. Distance from the pivot, 4 meters. Is equivalent to, now here you have to be careful. I'm dealing with effort 1. That means the arm should also be 1. When I go to effort 2, I also use effort arm 2. But in this case, I have to explain this very well because most of you make a mistake. I've done it like this because I know you normally get the effort arm 2 as x instead of getting the total distance from the pivot. That's where the mistake comes from. Right together? So let's have effort arm 1, effort force 1, that is 5, multiplied by the effort arm 1, that is 2. Okay? I'll love to introduce brackets here because we have 2 different operations. If you leave it like that without brackets, still you can get confused. Okay? Effort force 2 is 10 multiplied by effort arm 2. Effort arm 2, this is where the problem is. We are looking at the distance from the pivot to effort force 2. From the pivot to effort force 2. In this case, all candidates should know that the distance from here up to here is got by adding the 2 meters plus the x meters we don't know. So in this case, the distance will be 2 plus x, not x, because x is just from here. Are we together? From there, then we have 2 meters here. 2 meters is only working for this effort force 1. Are we together? So candidates don't misfire here. Therefore, we have the effort arm 2 as 2 plus x. That is the total distance from the pivot here to the effort force 2. Are we together? Therefore, let's have our effort arm. We are multiplying it by 2 plus x. Still, I told you always introduce brackets such that you don't get confused. All right. We shall multiply here, that is 50. If you can't multiply straight away, please, I advise use side work. You can multiply using your side work, but 15 times 4, 5 times 4, that is a 20. You write your 0, okay? Remember to carry a 1. This is side work. You have to do side work, okay? So 4 times 1 is 4, then plus the 2, that is 6. So we shall have 60 there, that is one side, is equivalent to 5 times 2 is 10, plus 10 times, we have to open the brackets here. 10 multiplied by 1 digit there, then another 10 multiplied by x. So 10 times 2 is 20, okay? Then we shall add this 10 times x, which is 10x. After reaching here, everything is solved. No other bond that we have to crack. We have cracked all the bonds. I'll go back a bit here. Opening brackets, if you're not well conversant with that, you get the 10 and multiply by each of these in the brackets. So 10 times 2, you get the 20. Then 10 times x, you get 10x. As simple as that. All right. Let's go on and solve our equation. We have finished to form the equation. Let's solve it. We shall still have 60 this side. You know our next step is to collect like terms. But before you collect like terms, these 2 can be added. 10 can be added to 20. So we shall have 30, okay, plus 10x. We are just simplifying, We don't want things to look so hard, okay? Now, our next step is to subtract 30 from both sides, okay? That is how you collect like terms. You subtract 30 from both sides, even here, 30. So we shall have, okay, you can start from this side, 30 minus 30 plus 10x. If this confuses you, you can rewrite it. You can rearrange. you can have 10 plus 30, then you have 10x plus 30 minus 30, then this side you have 60 minus 30. Still works, the same thing. All right, 60 minus 30, okay? So 30 minus 30 is a 0. That one is obvious. 30 minus 30, 0. So this side we shall stay with it at 10. You can write the 0 there if you want, or cancel, okay? Plus 10x is equivalent to 60 minus 30, we shall have 30, okay? So we shall have 10x equivalent to 30. Our next step is to divide by 10 on both sides in order to stay with it, x. So divide by 10 on each side, okay? 10 divided by 10 once, by 10 once. We shall stay with the x that side. Here we shall have, you can even cancel the zeros, okay? Whenever you have zeros, you cancel them, then you stay with 3 out of 1, which is 3, okay? So our candidates, the value of x in this case is 3 meters. 3 meters, so x, we have x as 3 meters. X distance is equal to 3 meters, okay? Now, there are some situations where they can ask you to find the length of the plank. Those who were with us in the previous lesson must have seen this. Your work is only to add. If the question was, find the length of the plank, when they have given you an unknown value here. So your work is to come and add. The length of the plank will be 4 meters plus 2 meters plus 3 meters. Are we together? That's how you can get the length, the total length of the plank. Are we together? But in this case, they told us only to find the value of x, as simple as that. So let's look at another example. We have just 2 examples to go for today's lesson. Let's look at example 3. In the same manner, we shall solve it the way we've been solving the previous examples. Take note, we are giving you many examples so that you can practice. Practice makes perfect. I don't want you to think these are very hard things, okay? You have to do this example, we shall also do this example, as simple as that. All right, we have here number 3. It states that find the value of weight W. Now, you realize in the previous example, we were looking at distance. In this case, things have really changed. We are looking at the effort force 2. We have to calculate what effort force 2 is. All right, let's go ahead and state the principle of moment, the load force multiplied by the load arm. Always state that, yeah, it does no harm, All right, then effort force times effort arm. As simple as that, okay? Now, let's first of all see what is given. What are we given in our example? We have here load force. 4 meters is the load arm. Are we together? We have 5 kilogram force. That is the effort force 1. We have 2 of them this side. Don't forget. What is the distance of effort force 1 from the pivot? Remember, the pivot is our turning point. You can also call it the fulcrum, okay? The distance of effort force 1 from the pivot is 2 meters. That is effort arm 1, okay? Then effort force 2 is what the examiner requires us to calculate. That is effort force 2, okay? We shall also multiply it by its distance from the pivot. In this case, we don't have any unknown. It is very simple. We shall add 2 plus 3. That is the total distance from here up to here. That is 5 meters. In other words, the effort force 2, the effort arm 2 will equal to 5 meters, okay? Don't forget that that is our new effort arm 2. Let's go ahead and substitute, okay? All right, load force, in this case is 15, multiplied by the load arm, which is 4 meters, okay? That should be equivalent to the effort force 1 times the effort arm 1, added to effort force 2 multiplied by its distance from the pivot. As simple as that. So effort force 1 is 5 kilogram force multiplied by its distance from the pivot, that is 2. Remember to introduce brackets because we shall have different operations coming in. Plus effort force 2 is an unknown. We don't know it. That is W is effort force 2 multiplied by effort arm 2, which we have already found out. Those who didn't understand how we got 5, we add 2 plus 3, because that is the distance of this weight from its pivot, not from here up to here. Don't make that mistake. It is from the pivot to the weight. Are we together? So we shall multiply this by the distance from the pivot of that weight, which is 5, okay, into brackets. There are different operations, okay? Make sure your work is really smart. We have already had 15 times 4, that is 60. I will not repeat that. All right? Is equivalent to 5 times 2 is 10 plus W times 5, that will be 5W. As simple as that. Now we have an equation where we have 2 sides and they have to balance. We said our seesaw should be in equilibrium, in a state of balance. So let's see how we can balance it. All right. 60, in this case, our next step is to subtract 10 from both sides. And by doing that, we shall have collected like terms. Don't just make the 10 cross this side. Please subtract. Show it, okay? You can rearrange this. In case you don't have negatives, it is easy to rearrange, okay? But I'll leave it like that. So 60 is equivalent to, 60 minus 10 is equivalent to 10 minus 10 plus 5W. 10 minus 10 is very simple. You get a 0. 60 minus 10, we shall have a 5. 50. 6 minus 1. Shall have 50 equivalent to this 0, then plus 5W. So 50 is equivalent to, we only have 5W this side. What is our next step? In order to start with W, we have to divide both sides by 5 such that we remain with W on one side. Divide by 5 this side, divide by 5 this side. Cancel by 5, divide by 5, 1. 5 divided by 5, 1. Shall stay with our W this side, equivalent to, by 5 once, 5 goes in 50. How many times? 10 times. Okay? So we shall have 10 this side. Don't forget to write it there. Some of you forget. All right, the examiner needs to know how you've got these answers all the way. Now, weight W is 10. Those who have time can always go ahead and prove their answers. Okay? That if I substitute 10 here, will it match? Shall I have the same weight this side and the same weight this side? If we have 60 this side, let's see whether I can get 60 this side. So if this is 10, 10 times 5 will give us 50, plus 5 times 2, which is 10. So we shall have 50 plus 10, giving us 60, which is equivalent to 60 this side. So hence, proved. Are we together? So therefore, our weight here is 10 kilogram force. As simple as that. That is what the examiner wanted. Okay? So we shall go to example 4. Example 4. Remember, dear candidates, I'm giving you many examples in order for you to get used. Practice. Okay? In the same way, it looks as if we have the same example, but no. In this case, we have 2 weights this side, and we have 2 weights this side. The previous example, we had 2 weights on one side and 1 weight on the other side. So 2 weights were supposed to balance 1. In this case, we have 2. Your 2 siblings this side, and you, and maybe someone else. Okay? Now, our first step is always to state the law of moment. Find the value of weight Z. Still, we have Z around there. Okay? But in this case, we have 2 weights. We also have 2 weights here. Let's state the law of moments. It states that the load force multiplied by the load arm should be equal to the effort force multiplied by the effort arm. As simple as that. That one can earn you a mark. It can earn you a mark. All right. Let's see what we have been given. That is the first step always. Here we have load force. In this case, let's call it load 1. Okay? We shall have this as load 2. But before that, we need to know the distance. Load force 1 is from the pivot. In this case, we have 3 meters. This one only ends here. Okay? Don't make that mistake. So we have 3 plus 2. In other words, our L1, in this case, LA1 is 5 meters. Okay? Always interpret your question properly. All right, let's go to L2. Load force 2. What is the distance from the pivot? In this case, the distance is very easy. From the pivot, the distance is 2 meters. So we shall have 2 meters as our load arm 2. Let's go to the side of effort. We shall have effort force 1 here. Its distance from the pivot is also effort arm 1. Let's look at effort force 2, effort force 2. Its distance from the pivot, remember to add the 2. That is 4 plus 2, giving us 6. So effort arm 2 here, in this case, will be 6 meters. Our work is to substitute. After laboring to find out what we have been given, our next step is to substitute, as simple as that. All right, let's go ahead and see. Load force multiplied by the load arm. Let's look at load force 1. In the case of load force 1, we shall have 30 kilogram force multiplied by its distance from the pivot, which is times 5. Put that in brackets first. Then you add. You add another force. Why are we adding? We have two of them. We don't have 1. So that's why we have to add. So let's look at load force 2. What is the distance of load force 2 from the pivot? That is the load arm. So load force 2 will be 40 multiplied by 2. 2 meters. Okay? Put that in brackets. That one should be equivalent to the effort force 1, 25 kilogram force, multiplied by its distance from the pivot, times 2. Put that in brackets, plus Z, which is unknown, that is effort force 2. That should be multiplied by its distance from the pivot, that is effort arm 2. That is 6 meters. Put that in brackets. Your work is now to remove the brackets. Very simple. All right. 30 times 5, if you can't do it from your head, mental work, please, I advise you use side work, okay? So we shall have 30 times 5, giving us 150, okay? Plus 40 times 2, that gives us 80, all right? That should be equivalent to 25 times 2 gives us 50. Let's put a 50 plus z is unknown times x times 6. We shall get 6z. Very good. Yeah. Our next step is to collect like terms. But before that, we can add these two. We can add these two. If you can't, please subtract 50 from both sides. Okay? You can subtract 50 from both sides in order to remain with 6z along this side and all of these on one side as well. Okay, I'll do the simplest. 150 minus 50 on this side plus 80 will give me 50 minus 50 plus 6z. I brought this 50 here because it is easy for you to subtract 150 minus 50. You get 100. Okay? That is 100 plus 80 will give me 50 minus 50 is 0 plus 6z. Okay? So let's add 100 plus 80. We shall have 180. 180 is equivalent to 6z. Yes, what shall we do in order to stay with z? We shall divide by 6 on both sides. Divide by 6 this side, divide by 6 this side. Okay? So 6 divided by 6, you get 1. 6 divided by 6, you get 1. What are we remaining with this side? We are remaining with z, which the examiner wants. Let's divide 6 by 6 here. We shall have 1. 6 goes in 180, 30 times. If you can't do that, please, I advise you use side work. Okay? By 6, once, 6 goes here, 30. Okay? That means our z is 30. So we shall have 30 as our z. Now, z is a weight, and it is measured in kilogram force. It is measured in kilogram force. So don't forget to write the units. Okay? So our z in this case, z is equivalent to 30 kilogram force. Always put the units. Always put the units. Remember in our previous examples, we've been putting the units as well. So if you don't put units, the examiner won't know what you're talking about. Are they goats? Are they chicken? So you need to be specific by putting your units. Dear candidates, that is all for today. I urge you to do more of these numbers. Practice them in your free time, and where you feel you're not comfortable, you can always reach us. Please remember to subscribe to our YouTube channel in order to get a notification whenever we upload any new video. See you again. Goodbye.